If you spend any time in tech forums, Steam discussion boards, or gaming subreddits, you'll run into a very particular kind of outrage. Purists are furious about AI-driven graphics technology. You'll see comments calling it a scam. This isn't real performance, it's fake, AI-generated, hallucinated pixels. The tech giants are using software as an excuse to sell us overpriced, under-engineered graphics cards instead of giving us honest raw computing power. And this isn't a fringe opinion limited to a few angry forum posters. When NVIDIA unveiled DLSS 5 at CES 2026 with real-time neural rendering, the reveal video on YouTube ended up sitting at roughly 84% dislikes. That's a substantial chunk of the gaming audience actively rejecting where this technology is heading. Today, I want to go through this properly. Modern graphics cards now rely on AI for two genuinely different jobs: image reconstruction and frame interpolation. They are built on different ideas, they solve different problems, and they deserve to be judged on different terms. So let's walk through both, look at the real engineering history, the genuine community debate, and where I personally land. Let's start with what DLSS actually is an AI technology in its own right. DLSS, Deep Learning Super Sampling, is a neural upscaling system. The game renders at a lower internal resolution, something like 1080p, and a trained neural network reconstructs that image up to your target resolution, say 4K, filling in detail intelligently rather than just stretching pixels. The model has been trained on enormous datasets of high-resolution reference images, learning to infer fine detail, edges, and texture from a lower-resolution input. Done well, this produces an image close to native resolution quality while requiring meaningfully less raw rendering work. Every frame DLSS upscaling produces corresponds to an actual frame the GPU rendered and an actual input the game received. The AI is reconstructing detail, not inventing new moments in time. Frame generation is a separate AI system solving a separate problem. Rather than reconstructing a rendered frame at higher resolution, a neural network analyzes two consecutive real frames, predicts the motion happening between them, and generates an entirely new synthetic frame to insert in between. If your GPU renders 40 real frames per second, frame generation can insert AI-generated frames between them to display 80, or with NVIDIA's newer multi-frame generation, even more, without the GPU doing the rendering work for those additional frames at all. The visual result can look dramatically smoother, but those inserted frames don't carry new input information. They are the AI's best prediction of what should appear between two real moments, not a faster response to what you're actually doing with your mouse or controller. Both are genuinely AI-trained neural networks doing real inference work in real time. But one is reconstructing image quality and the other is predicting motion. That distinction is the foundation for almost everything else in this video. And here's the clearest case study in how this technology gets oversold, worth walking through in detail. At CES 2025, Jensen Huang stood on stage and claimed the new RTX 5070, a $549 graphics card, would deliver performance equal to RTX 4090, a card that launched at $1,600. That claim rested almost entirely on multi-frame generation, closing the gap between two completely different tiers of hardware. NVIDIA's broader keynote leaned on the same trick to sell the rest of the lineup. To show off flagship RTX 5090, they demonstrated Cyberpunk 2077 running at 238 frames per second with full ray tracing enabled, using DLSS 4 and multi-frame generation. The number on screen was real, the framing around what produced that number was not. When independent reviewers got their hands on the actual RTX 5070, the picture fell apart almost immediately. In raw, native rendering performance, the RTX 5070 was roughly 5 to 8% faster than the previous generation's 4070 Super. Across a 16-game testing sample at 1440p, independent benchmarks found the RTX 4090 was on average 63% faster than the RTX 5070 in real rendering terms. Tech outlets did not hold back. Gamers Nexus called the comparison an absolute flat-out lie. Linus Tech Tips titled their review, "This is a 4090 killer and I'm a liar." Ars Technica described the card as hard to classify as anything other than a disappointment. The entire 4090 performance claim only existed in one extreme scenario, multi-frame generation, pushing the displayed frame count up dramatically, while the underlying rendering hardware was doing nowhere near 4090 level work. And critically, multiple testers reported the experience didn't feel like 238 frames per second at all. One reviewer testing the flagship RTX 5090 described it directly. The frame counter read over 200, but actual input response felt closer to 60 frames per second, creating what he called a slightly jelly feeling to the controls. The gap between what the number on screen says and what your hands actually feel is the clearest demonstration of why frame interpolation and image reconstruction need to be judged separately. And it's the single biggest reason purists have a legitimate grievance worth taking seriously. Now let's focus purely on DLSS, the reconstruction side, because its story as an AI technology is genuinely its own. When NVIDIA first introduced DLSS, the original version, the tech community tore it apart, and they had a point. It was blurry. It introduced visible ghosting. The neural network simply hadn't been trained well enough yet to do the job convincingly, but the underlying models kept improving. Spatial reconstruction gave way to temporal accumulation, feeding the network information from previous frames, not just the current one. And the architecture moved toward dedicated machine learning hardware built specifically for this task, alongside more sophisticated training methods. Which brings us to DLSS 4.5 today. Computer Base ran a blind test in early 2026 across 6 demanding titles at 4K: Anno 117, Ark Riders, Cyberpunk 2077, Horizon Forbidden West, Satisfactory, and The Last of Us Part 2. Nearly 6,750 votes were cast comparing DLSS 4.5, FSR 4, and native rendering with no labels attached. DLSS 4.5 won decisively, taking 48.2% of all votes, with native rendering at 24% and FSR at 15%. Voters with no idea which image was which preferred the AI reconstructed image over the native one almost twice as often. As an AI image reconstruction system, DLSS has genuinely earned its current reputation. That's a completely separate verdict from how multi-frame generation gets marked, which is the part that deserves the actual skepticism. Now let's address something I find genuinely funny about this whole debate: the framing of fake pixels as some kind of unique betrayal, specifically when it comes to AI reconstruction. You are at this exact moment sitting down to enter a digital environment where the lighting is a mathematical approximation. The physics are simulated within deliberately simplified rules, and every character on screen is a hollow 3D mesh wrapped in a painted texture. The entire medium of gaming is by its fundamental nature an engineered illusion. Every anti-aliasing technique used for the past 15 plus years has done its own version of this approximation. DAA, FXAA, MSAA. They all blur, smooth, or estimate pixel values to hide jagged edges because rendering perfectly clean geometric lines at native resolution in real time has never been realistic. AI-driven reconstruction is simply a smarter, learned version of a trick this industry has relied on for its entire modern history. In fact, NVIDIA's DLAA, their AI-driven anti-aliasing mode that doesn't even upscale, just cleans up a native image using the same neural network architecture, is now widely regarded by the same community as legitimately better than traditional TAA, not just a passable substitute. That's the part of this technology that's earned its place fairly. So with both AI systems laid out clearly, let's talk about where the genuine criticism in this debate actually belongs. The first legitimate complaint, well documented across Steam discussions and tech forums, is that developers are increasingly leaning on AI upscaling as a crutch to cover up unfinished optimization, rather than as a genuine enhancement layered on top of already solid performance. Several recent AAA titles struggle to hit smooth frame rates even on flagship cards at native resolution, with the unspoken assumption baked into the marketing that you'll just turn on DLSS to compensate. That's a fair criticism of certain studios' priorities, not of the reconstruction technology itself. The second, and frankly larger problem, is exactly what we've just walked through with the RTX 5070, using multi-frame generation's inflated frame counter as a substitute for genuine rendering improvement, then marketing that number as if it represents the same kind of performance gain as a real hardware generationally. That's not a flaw in the AI doing the predicting. That's a presentation problem, and it's one NVIDIA created for itself. Search any recent releases Steam discussion page for frame generation specifically, and you'll find genuinely useful recurring patterns from real players. Across discussions on Stalker 2, Monster Hunter Wilds, and Battlefield 6, the same conclusion comes up again and again independently. Frame generation feels excellent above a baseline of roughly 60 frames per second, and feels genuinely bad below it. One player described enabling it at a native 20 to 30 frames per second and ending up with input that felt like wading through mud, even though the on-screen counter claimed 60. Another made the technically accurate point that frame generation doesn't make your inputs land faster. The AI is only predicting what the image between those inputs should look like. If your real frame rate is 20, your actual responsiveness is still tied to 20, no matter what the frame counter displays. There's also a recurring debate about controllers versus mouse and keyboard, and it's more complicated than the simple version of the story. The general pattern is that controllers tolerate the added latency more easily, but plenty of players report the opposite in specific games, describing input delays severe enough to feel almost unplayable, which usually traces back to a bug in the game's specific implementation rather than the underlying technology. Frame generation issues and outright bugs get blamed on fake frames interchangeably online, when they are often two separate problems. The most consistent piece of advice across nearly every one of these threads, regardless of the specific game, is almost identical. Don't enable frame generation unless your native baseline is comfortably above 60 frames per second, and use NVIDIA Reflex or AMD's equivalent latency mitigation alongside it. And this brings me to something specific to the motion prediction side of this technology. DLSS reconstruction behaves quite differently here. Frame generation, by its very design, adds latency between your input and what you see on screen, because the system has to hold back a real frame, wait for the next one to arrive, generate the predicted frame in between, and only then release everything to your display. That delay is small in absolute terms, but it is real, and it compounds with however much latency already exists in your setup. For slower-paced, single-player, narrative-driven games, open-world exploration, story-heavy RPGs, anything where split-second reaction time isn't the determining factor in whether you succeed, that small latency cost is a completely reasonable trade for a much smoother visual experience. That's the use case frame generation was genuinely built for, and where it delivers real uncomplicated value. But for competitive, fast-paced online games, first-person shooters, fighting games, anything where the difference between winning and losing comes down to milliseconds of reaction time, frame generation is the wrong tool entirely. In that context, every fraction of a millisecond of added latency matters, and a smoother-looking frame that arrives later is a genuine disadvantage, not a luxury upgrade. The correct approach in the competitive titles is the opposite philosophy. Squeeze out every bit of real, native frame rate your hardware can deliver, using DLSS upscaling if needed to lighten the rendering load, but leaving frame generation off entirely. You want the game to respond to you as fast as physically possible, not to look as smooth as possible. Those are different goals, and competitive gaming has a clear answer about which one wins. So let's consolidate this into one clear, practical framework, treating each AI system on its own terms. For DLSS upscaling, use it almost everywhere. In quality mode, it's frequently indistinguishable from or better than native resolution, costs you nothing meaningful in responsiveness, and gives you significant rendering headroom. This applies whether you're playing competitively or casually. For frame generation, reserve it specifically for single-player, cinematic, slower-paced games and only once your native baseline, ideally boosted by DLSS upscaling, is sitting comfortably above 50 to 60 frames per second. Pair it with NVIDIA Reflex or AMD's Anti-Lag 2 to minimize the added delay. Never use it to rescue an unplayable frame rate, and never use it in competitive online games where reaction time decides outcomes. Independent testing has measured DLSS displaying roughly 80% less latency than FSR on average in frame generation scenarios at 4K, a gap that matters enormously on a 240 Hz competitive display and matters far less in a slower single-player game on a controller, which is exactly the use case where frame generation belongs in the first place. Personally, for single-player, story-driven games on a controller, hitting a genuine native 60 FPS baseline before enabling frame generation gives me zero noticeable input lag. For anything competitive, I don't touch frame generation at all. I push native performance as high as it will go and let DLSS upscaling do the heavy lifting if I need extra headroom. Here's something that I think most people in this debate are missing entirely, and it changes the framing of everything we've been talking about. The conversation around DLSS and frame generation is almost always treated as NVIDIA story, or at most an NVIDIA versus AMD story. But the reality in 2026 is that these technologies have already escaped the boundaries of any single manufacturer's ecosystem, and they are spreading in ways that nobody anticipated even 3 years ago. Take lossless scaling. It's a third-party application, not made by NVIDIA, not made by AMD, that you can buy right now on Steam Store for roughly $7. $7, at its core, it is an universal upscaler, hence the name, built using machine learning designed to work on most games and specifically engineered to run on a wide range of GPUs, including integrated graphics. Not a flagship RTX card, not an RX 9000 series. Integrated graphics, the chip soldered onto your laptop's processor. And on top of that upscaling foundation, it's also offers frame generation, giving you both technologies in a single lightweight application for the price of a coffee. What this means in practice is remarkable. With this single Steam purchase, you can get most of the benefits of DLSS 4 and AMD's FSR even without the latest graphics cards. Old games that were never designed with any upscaling or frame generation in mind, games from 10 or 15 years ago, games that will never receive a developer patch adding DLSS, all of them can now benefit from AI upscaling and frame interpolation through a third-party overlay. The technology is no longer gated behind specific hardware generations or developer support decisions. And it's expanded further than that. By 2026, lossless scaling runs on Steam Deck via a one-click plugin in the Decky store, letting users set 2x, 3x, or even 4x FPS multipliers live during gameplay, with settings adjustable without restarting the game. A handheld gaming device running a library that spans decades of PC games now has access to both AI upscaling and frame generation through a community plugin. That's not a niche enthusiast experiment anymore, that's mainstream. The important caveat is that third-party upscaling and frame generation applied externally without game engine integration has real limitations. Without the motion vectors and depth information that a natively integrated solution like DLSS can access from inside the game engine, the interpolated frames can produce more visible artifacts in fast motion, and the quality ceiling is lower than what DLSS 4.5 achieves natively. The upscaling side faces similar constraints. Without engine-level data, reconstructing fine detail in complex scenes is harder than it looks from the outside. But the gap is narrowing, and for older or less demanding titles, the results are already genuinely impressive. The point isn't that lossless scaling is as good as DLSS. The point is that the underlying technologies, AI driving image reconstruction and motion prediction, have become so accessible, so portable, so broadly applicable that they are clearly no longer features you opt into when you buy a specific graphics card. They're becoming a foundational layer of how games are rendered, regardless of what hardware you're running. Which brings me to the part of this conversation that I find most interesting and most telling about where we're actually heading. The people arguing most loudly about fake pixels and fake frames are in many ways fighting a battle that the industry has already decided. Because the next generation of consoles, both of them are being built around these exact technologies as core architectural principles, not optional software features bottled on after the fact. Let's start with what's actually confirmed. Sony's lead hardware architect Mark Cerny, the person who designed the PS4, the PS5, and the PS5 Pro, gave an interview to Digital Foundry earlier this year in which he confirmed that an equivalent frame generation library will appear on PlayStation platforms. He also confirmed something technically significant: the core algorithm underlying PSSR, Sony's AI upscaler, and AMD's FSR Redstone are identical. Developed through the Project Amethyst co-engineering partnership between Sony and AMD. The same neural network model shared between a PC GPU manufacturer and a console maker. The walls between these ecosystems are dissolving at the hardware level. Cerny was explicit that this frame generation technology won't ship in 2026, which points clearly to the PlayStation 6 as its destination. And the PS6 architecture reflects exactly this priority. Through Project Amethyst, 3K technologies are expected in the next PlayStation. Neural arrays, compute units grouped to function as an unified AI engine for upscaling and denoising, universal compression, and a dedicated neural processing unit to handle machine learning tasks. A dedicated chip inside the console specifically for AI rendering work. That's not a PC feature being ported to console. That's a console being designed from the ground up with AI rendering as a first-class citizen. The next Xbox is heading in the same direction. Both machines expected to emphasize AI-accelerated upscaling and ray tracing rather than raw resolution as the primary measure of performance. Microsoft's Sarah Bond described their next hardware as a portfolio approach spanning console, handheld, PC, and cloud, all sharing the same ecosystem. The era of brute force resolution as a headline console specification is essentially over. And that's the most revealing thing about where this debate actually stands. The companies who have everything at stake, who need to sell hardware to hundreds of millions of people, who cannot afford to bet the next 7 years console generation on a technology that turns out to be a gimmick, have all independently reached the same conclusion. AI upscaling and frame generation are not a compromise, they are the path forward. Now, that doesn't mean every implementation will be good. The RTX 5070 launch proved that these technologies can be mispresented and oversold. The developer optimization problem is real. The competitive gaming latency concern is real and legitimate. None of that disappears because Sony and Microsoft have decided to build neural processing units into their next consoles. But the question of whether AI rendering belongs in serious gaming hardware has been answered. The answer is yes, emphatically, architecturally, irreversibly. The only remaining debate is about how well it gets implemented and how honestly it gets communicated. I want to be fair to other side here, because once you look at these two AI systems on their own merits, and once you look at where the entire industry is heading, the purist position actually splits into two very different arguments, one fair and one less so. The argument against AI image reconstruction as a concept doesn't hold up well anymore. The blind test data is real, the image quality has genuinely arrived, and the fake pixels framing applies just as much to 2 decades of anti-aliasing techniques nobody complained about. The technology has been adopted by third-party developers, democratized to run on budget hardware and handheld devices, and baked into the silicon design of the next console generation. That is not the trajectory of a gimmick. The argument against how multi-frame generation has been marketed using an inflated input-disconnected frame count to claim performance parity with hardware a full tier above its actual capability is completely fair, and the RTX 5070 launch is the clearest evidence of exactly why that skepticism exists. NVIDIA earned that particular backlash, and the industry should hold them to a higher standard of honesty in how these numbers are presented. Those are two separate arguments. One of them has been answered by the technology itself. The other is still waiting on the marketing to catch up. So, where do I land on this? DLSS upscaling, the criticism has largely been answered by the technology itself. It's excellent, and treating it as an inherently fake or inferior doesn't match the evidence, the blind test data, or the direction the entire industry is moving. Frame generation, genuinely valuable, but only if the specific context it was built for. A strong baseline frame rate, a slower-paced single-player game, and a clear understanding that the number on your screen and the responsiveness in your hand are not the same thing. Use it correctly, and it's a real upgrade. Use it to rescue bad performance, or use it in a competitive shooter, and you're working against it rather than with it. And at the bigger level, whether any of us like it or not, AI rendering is no longer an optional extra on high-end PC hardware. It's the foundation that the next generation of gaming is being built on, across PC, handheld, and console simultaneously. The debate isn't really about whether it belongs. It's about making sure it's implemented honestly, communicated accurately, and used intelligently. That's my honest take. Are you someone who keeps frame generation off entirely, or do you use it selectively? Tell me in the comments. I am curious where you stand now that we've gone through all of this. Subscribe if you like more of this kind of breakdown. I'll see you in the next one.